Welcome again. This is the next session from grade 10 CBSE syllabus, chapter 1 chemistry, chemical equation, chemical reaction and equation. So in this point we are going to study about chemical reaction, chemical equation and how to balance chemical equation. So to understand for this you need to first recall your grade 9 chapter where you have studied how to write chemical formula and the balances of basic elements. You need to have a proper idea of balances and how to write chemical formula. So if you know these two things, then this balancing the chemical equation and writing chemical equation will be very easy for you people. Don't get confused with the valency of the element and charges on radicals. So if you get confused with that, you will be confused in balancing as well as writing chemical formula. That particular point we will discuss in detail in next upcoming videos, but for now we will discuss about what is chemical reaction, equation and how to balance chemical reaction. So in previous video we have observed different chemical reactions, different chemical change. Wherever there is chemical change occurring, what happens? There is definitely a chemical reaction happening or occurring. For example, when milk turns into curd, that is curdling of milk. So it is very simple example, we observe it in our day-to-day life. So what actually happens? This is very good example of chemical change where due to the bacteria present in milk, the bacteria changes lactose sugar into lactic acid. So here see, a chemical change is happening, a chemical change is occurring. Lactose sugar is converted to lactic acid. Now due to this conversion, the acidity of the system is increased. Now due to this increase in acidity or the pH of milk, the casein protein precipitates, and the casein protein which is precipitated we call it as curd, and you can see the water layer above. So this separation of these two substances is happened or is possible due to one reaction which is happening in the system, and that is lactose sugar converted to lactic acid due to presence of lactobacilli. So it is very simple to understand. So wherever there is chemical change occurring, there is a chemical reaction. So what is chemical reaction then? So we have seen in detail about chemical change and physical change. So you can define chemical reaction. Chemical reaction is the process where atoms, ions or molecules, sometimes radicals, atoms, ions, molecule, radicals, all these things can be rearranged, and after the rearrangement there is formation of new substance. Now for example, let's take an example here. So the example is NaOH plus HCl. Okay, now both are ionic compounds. So here we are talking about ions. NaOH, that is sodium hydroxide, when reacts with HCl, what happens? What happens? A simple salt, that is NaCl, is formed plus one water molecule is formed. Now all these solutions react with each other in aqueous medium. Aqueous medium. Now what is aqueous medium? When we make water solution of any substance, it is called aqueous medium. So NaOH, HCl reacts with each other to form NaCl and water. Now how the ions are rearranged? So here this dissociates into Na plus OH minus. Here it dissociates into H plus Cl minus in aqueous solution. Then what happens? Na and Cl reacts with each other to form NaCl. Okay, and remaining OH minus and H plus As you know that positive and negative have forces of attraction. So they get attracted to each other as they are remaining alone, and therefore they too get attracted to each other and forms ionic bond, and then here water molecule is formed. Okay, so you have studied about different bonds and what are chemical bonds and all, so I am not going in detail for that, but this is called rearrangement of atoms, ions, molecule, radicals, because here OH acts as a group of atoms. It is actually a molecule which have negative sign on it, which have negative charge on it, and therefore it acts as a radical. Okay, Na plus is ion and Cl minus is also ion. Okay, so here ions are rearranged and the new substance is formed with totally new properties. Okay, and therefore chemical reaction is occurred, chemical change is occurred, and this chemical reaction we are going to study in detail. Okay, now this you can see, if I want to write a whole sentence that sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. So it will be very big, 2-3 lines I may require to explain the reaction, and to read the reaction it will take much time. So to represent it in very concise manner, in very proper manner, in compressed manner, okay, in micro manner, we have a new chemical equation is used to represent a chemical reaction in concised manner, in very simplified manner. Because see, suppose if I write sodium hydroxide reacts with hydrochloric acid to form sodium chloride and then we get water, so it will be very long sentence. I require 2-3 lines to explain it, to write it, and then to read it. Many details I have to add in the reaction when I write it in sentence, so it will be bulky. So to make it concise we use chemical equation. Now any equation has two sides, and what are the two sides? It is LHS and RHS, that is left hand side and right hand side. Now in left hand side and right hand side is separated by an arrow. So if you know in maths uses equal to sign, but here we will not use equal to sign because we are showing process. Here a chemical reaction happens in a process. So here we are showing a process, and therefore we will show arrow. Now let's have the same reaction here. I'll explain with the same example. Sodium hydroxide reacts with hydrochloric acid to give NaCl, that is sodium chloride, and water. Okay, so in LHS we have more than one substances who are reacting with each other, so we are showing it with plus sign. In RHS also we are getting more than one substance, therefore we are adding plus sign here, and again to separate both sides we are using arrow. Okay, still this reaction is not complete. Okay, this equation is not complete. We need to balance it. How to balance that we are going to study within no time. But then to understand this reaction first, see what we have written in its LHS: substances who are reacting with each other. So they are called as reactants. And in RHS what we have written? Substances which we got after the reaction. So it is output. Output is generally called as product. So in RHS we write products. So LHS is reactant side and RHS is product side. And then this is whole chemical equation. Now this chemical equation represents both sides: chemical change, rearrangement of atoms. But you can see here the molecules or the atoms which are involved in the reaction are same: sodium, chlorine, hydrogen, oxygen. Okay, but they are not same as in reactant side. Okay, there is rearrangement, but there is no addition of any new element here. Only same 4 elements we can observe in LHS, and the same 4 elements are there in RHS. Okay, but the number of elements is changed. So here you can see there is hydrogen. Okay, 2 hydrogen, they were not together before, but now they are together, H2. This oxygen was with in NaOH, now it is separated and it is in water. Okay, and this Na and Cl are rearranged to form sodium chloride. So here rearrangement of elements plus number of elements in a particular compound is also changing. Here you can see that both the sides are balanced. Number of atoms are same, they have not changed. But this isn't the case for all the reactions. So wherever there is change in number of elements, same elements, but in RHS there are different, and in LHS the number is different, then we need to balance the reaction with respect to law of conservation of mass. Due to law of conservation of mass, we need to balance the chemical equation. Now, how to balance chemical equation? Now that we will see now. Okay. Now let's take example, very simple example of burning magnesium reading. I have written one example here on board. Let's read. When magnesium reacts with oxygen, that is in presence of air, forms magnesium oxide. Okay, now this reaction, again you can see here I have to take many words, 2-3 lines I have to write, and then I can write the proper reaction. So to make it concise, we will use here the symbols. But before symbols, where there is a word equation also, where we can write magnesium plus oxygen gives magnesium oxide in word form, and that reaction is called as word equation. But that equation we are not going to write here. We are going to write directly using symbols. Okay, so write the chemical equation here very simply. Magnesium, when reacts with oxygen, forms magnesium oxide. Okay, understood? This is the representation of the chemical reaction. Now here we need to write a chart showing the tally of or the amount of number of all the elements present in both sides. So to make that, we need to make a simple chart, LHS, RHS, and these elements. Now what are two elements present in the reaction? Simple, Mg and O, oxygen. Okay, let's count the elements present in LHS. How many magnesium? 1. In RHS, how many magnesium? 1. In LHS, how many oxygen? 2. In RHS, how many oxygen? 1. So we can't say that one oxygen is reduced or one oxygen is lost. We can't lost. Okay, we can't lose this oxygen. What we have to do then? We have to balance chemical equation, and then there will be representation of proper chemical equation, a chemical reaction, and that equation will be called as balanced chemical equation. So how to balance it? Now, very simple maths we have to do here. Magnesium is balanced here, so no need to balance magnesium. Let's balance oxygen first. Now in LHS I have 2 oxygen and in RHS I have 1 oxygen. So to get 2 oxygen in RHS, what I have to do? Yes, I have to multiply it. Okay, I can add 1. Okay, here I can add 1 plus 1. But where I will write plus 1 oxygen? I can't change the chemical formula here. So plus 1? No, I can't write plus 1. So instead of using plus 1, I have to write multiply 2. Okay, then what will happen? Both sides I will get 2 oxygen. Okay, so here where I should write 2? Here No, the chemical formula is changing. I can't change chemical formula. Here, no, again the chemical formula is changing, and that 2 will not be fitted there. So I can't write 2 here. Okay, so where I have to write? I have to write it here. Now in mathematics, you have solved quadratic equations. Wherever we don't know the value of any substance, we write it x. Okay, suppose I have something and A has something and B have double of that something. So that something we have to consider as x, and double of that something will be 2x. Correct? So 2 we add here. So this 2 is constant or coefficient. So we add constant or coefficient in this manner. Okay. Now what happened after adding 2? Now can I say the reaction is balanced? Definitely no. Because due to addition of 2 here, number of magnesium in RHS is also changed. Number of magnesium is changed. Now 2 magnesium. But here in LHS there is only 1 magnesium. Okay. So what I should do to balance magnesium here? I have to again multiply by 2. Here I will write 2. Then the reaction is balanced. Now if we want to read the reaction, how we will read it? We can read it, see, when 2 atoms of magnesium react with 1 molecule of oxygen. Are you understanding the point? See here, when oxygen reacts O2, here we have written O2, not 2O. O2 is 1 molecule. 2O is 2 atoms. Okay? So here 2 magnesium means 2 atoms of magnesium react with 1 molecule of oxygen to produce 2 molecules of magnesium oxide. Now here magnesium and oxygen, they are combined. So this is not a element, this is a compound. So compound is always in the form of, always in the form of molecule, and therefore 2 molecule of magnesium oxide. And now the reaction is balanced, but it is not complete. So to understand the reaction, we need to add more details. Now what are the details? So magnesium, how magnesium is reacting? Is it in liquid form, solid form, gaseous form? We need to add state of matter. So obvious, magnesium is solid in nature in the reaction. Oxygen is gaseous in nature in the reaction. And what magnesium oxide, what we have got is solid again. Okay. Still reaction is not complete, because if I keep magnesium ribbon like that, will it burn? No, we have to provide a heat source, and that's why we can add delta here, which represents heat, or we can write in words heat. Okay, you can add color, name of substance, like here I can write magnesium reacts with oxygen to produce magnesium oxide. I can add color also here, white residue, white powder. Okay, magnesium is silvery white, oxygen is colorless. Okay, now have you understood how to balance the reaction? First, you need to count all the elements present in LHS, number of elements present in LHS, and the same number of element, their number will be changed in RHS. So count that, write that, and do it properly. When you practice it more, you will not need this table. You will do it just orally by just saying or by counting the numbers. Now let's take another example. Now here we will just balance the chemical equation here. Okay, let's take an example of H2SO4, ZnSO4 and hydrogen. Okay, now here see how many zinc, how many elements are present first? Zn, hydrogen, sulfur, oxygen. Okay, now let's count Zn in LHS. How many Zn in LHS? Okay, here 1 and here also 1. Zn 1 1. Hydrogen here in LHS 2. Here in RHS 2. Then sulfur in LHS, sulfur in RHS 1. Oxygen in LHS, oxygen in RHS 4. So you can see here we don't need to balance the chemical equation because it is already balanced. Okay, because it is only rearrangement of valencies and atoms, and therefore we don't need to balance the chemical equation. Okay, now let's take example of next chemical equation. Again steps, we will go through steps. Okay, what we have to write? First the elements which are involved in the reaction: iron, hydrogen, oxygen. Now count number in LHS. In LHS 1, hydrogen 2, and then oxygen here 1. In RHS count the number: Fe 3, hydrogen 2, oxygen 4. So first let's balance oxygen, because the number of oxygen in RHS is more and here it is less. So we will first balance oxygen. So here to get 4 we need to multiply it with 4. Okay, we need to multiply in RHS. So here if we will write 4. Now what happened here after writing 4? Other number is still the same, but hydrogen number in LHS is changed. 4 2s are 8. It became 8. And here in the LHS, oxygen number is now balanced 4 4. But due to that, hydrogen number is changed. Now let's balance hydrogen in RHS. Now to get 8 here, what we need to do? We need to again multiply it with 4. Okay, 4 2s are 8. So here we have got properly 8 8. Okay, now what is not balanced here? Iron. Iron. How many iron here? In RHS 3, but in LHS only 1. So what we need to do? Very simple. Multiply with 3 right here. 3. So after multiplying with 3, we got the balanced chemical equation. Let's write the balanced chemical equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. Gas is liberated, so upward arrow we have to show. Then iron in solid nature, H2O in gaseous nature, iron oxide again we get solid, and H2 is gas. Now why I have written H2O in gaseous nature? Because in this reaction iron is reacting with steam. So this reaction represents here water is in the form of steam. Okay, and therefore this reaction is occurring, and this is the final balanced chemical equation. So I hope you have understood what is chemical reaction, what is chemical equation, how to write chemical equation, and how to balance chemical reaction or chemical equation. Practice it. You know this is not needed at all when you will balance chemical equation properly. Okay, so I hope you have understood today's point. So if any question, please you can ask in comment box. Bye for now. We will meet soon.